What's going on, everyone? We're gonna get started in just a couple minutes. Let me know in the chat if you can hear me okay. Okay, sounds good. Let me just get everything set up here. We'll get going. All right. I think everything's set up. So we're gonna get going. Hope everybody's having a great Saturday. Thanks for coming to the stream. Before we get started, I wanted to let you know that we are doing APIs today, designing and building REST APIs. So if you have any 1v1 me in Rocket League, let's do it right after stream. We'll do it. We always have an engineer man Rocket League sort of thing after stream. So feel free to join in. The So we're doing APIs. If you have any questions about APIs, go ahead and put it in the chat, and then it might get answered live. You can ask things like architecture questions about APIs, programming languages about APIs, infrastructure, how things fit together, pretty much anything you want. This stream is all about APIs, building them, designing them, use cases, things like that. So if you have any questions, put them in the chat. They'll get forwarded over to me, and then if I have enough time, I'll answer all of them live. As far as channel updates and announcements, not a whole lot on that front. I'm still working on the 200K video, which will probably be a 250K video now, and I expect that to be coming out soon, so be watching out for that. Other than that, there's not a whole lot to announce. Everything's going really well. Videos are coming out on time. Discord's functioning really well. Everybody seems to be benefiting from everything going on in the channel. So I can't think of a whole lot of things to announce that I haven't announced already in the past. So I think we'll just kind of just jump into the content. We have a lot to cover. I was going to write a lot of the code live, but I changed my mind on that. I actually wrote it all up front. And so what we're going to do is I'm going to basically like bring code into view a little bit at a time, and then we can kind of look it over and then talk about what it does. And the stream, we are going to be writing in JavaScript, but if you're not a JavaScript programmer, that's not a big deal. The stream is more about APIs themselves rather than the actual language that could write the API. You could write this API in anything, whether it's JavaScript, Python, Java, C Sharp, Rust, whatever. It doesn't really make a difference. So try not to get hung up on the fact that it's JavaScript because it's more about APIs in general. And I tried to make the code as simple and clean as I could just to remove sort of the language from the equation. I'm hoping I can just show people examples and say, this is sort of the main things that happen in the code, but you could have very well implemented this in any language. Okay, let me check out some questions here. Limitless asked, what are some common limits of APIs? So there's two types of limits you could run into with APIs. The first is like an API imposed limit. We're going to talk a little bit about that later. APIs often rate limit access to specific endpoints to say like 10 per minute, 60 per minute, 500 per minute. It just depends on what exactly that endpoint does and how much they want to limit it. The other possible limit would be capacity. Do you have enough hardware to service all the requests coming into an API from all the clients? So I'm not sure which you meant there. I don't know if you meant the hardware piece or the actual software piece, but the software piece is always user defined, and it's always based on the actual design of that API up front, saying that, we don't want you to send more than, like Discord API, for instance. They have a rate limit on the messages endpoint to ensure that you can't send 500 messages a second. After you send, say, 10 in a second, they just cut you off, and then the API lets you know you've been rate limited, with a HTTP code 429, and it lets you know that you can try again in, 700 milliseconds or whatever. Everyone's on Duncan. What's the difference between REST and RESTful? I'm actually going to be answering that kind of as part of this series, so I'm just going to skip that one. Actually, if you look at my, let's see here. Like my very first thing was REST API, normal API versus REST API, so we'll cover that in a sec. I think it's Lutzleem. What database do you recommend for modern applications, real-time game, for example? Is MySQL still viable for modern applications? I think it just depends on your use case. If you want a rigid schema and you want data that's really durable and you want to be able to do transactions, then MySQL is a sensible choice. But if you're working with big data and you're less concerned about durability and you're more concerned about storing large amounts of data across tons of servers and accessing that data really quick, then of course there's better options. You can start looking at things like Mongo or Elasticsearch, things like Cassandra. Limitless asked another question. What different API architectures are there, and what would you prefer people with low experience start with? So we'll be covering that in the context of this video as well. Samuel Hill, open APIs in the future for blockchain. So there are, so there's of course simple blockchain mechanisms, but then there are complex blockchain mechanisms, things like Ethereum, that actually have like their own programming language built in, and they have things that interact with the big Ethereum blockchain, smart contracts and whatnot. And of course, all those use some sort of API to access. Are they the future? I mean, blockchain, in the grand scheme of things, is still sort of new. So I don't know if everything would be on blockchain. I'm not even sure if that's what your question is. I think suffice to say that APIs have a big role in blockchain, and that's probably the best thing to say for that. How to best restrict access to the API, like tokens, etc. Yep, we're going to be... Yeah, let's just go ahead and jump in, because a lot of these questions are stuff I'm going to talk about anyways. So let's just jump into the content. And you can keep asking your questions. I'll review the questions kind of as the video progresses, and I'm happy to answer it at any time. So if you have additional questions as I go, feel free to interact in the chat, and then I will try to answer it live. No problem. Okay, so kind of the start of it is, you came here because we're talking about REST APIs and you want to know about designing and building them. But first, what is a REST API? And a REST API, REST stands for Representational State Transfer. And to be a REST API, it has to conform to a certain number of constraints. Like to be a true REST API, it has to strictly conform to all the REST constraints. Now, it's actually quite difficult to make a true REST API. So I like to make things that are RESTful in nature, ones that are almost a full REST API, and ones that implement sort of the sensible things. The whole REST API comes from a doctoral dissertation by a guy named, I want to say, was it Richard Felding? I think Richard Fielding. I don't remember his exact name, but he came up with this concept in a doctoral dissertation, and people sort of adopted it as kind of a loose standard on what your API would need to do to be considered, a REST API. So what I'm covering is sort of the 5 things that I thought were sort of key that all REST or RESTful APIs should be, but there are more that you can go further to make it even more RESTful, but here's sort of the common ones. And so first is like, what is a normal API versus a REST API? So, API is kind of a broad term in the abstract. API can be applied to any number of things. It can be applied to programming languages, for instance. Like Python has an API, and that API describes all of the things that you can do with the language. So it says, we have strings in Python, and then here's the API on things that interact with strings, for instance. So like .split would be part of the Python string API. So APIs are very broad, but in the sense of network connected APIs, we sort of have these normal APIs and these REST APIs. So if you have a network connected application and you have a backend service that renders some data to a front end, one could call that an API. But if it doesn't conform to some of these things that actually make an API a REST API, then it's sort of just a normal one. So any kind of backend can be thought of as an API. So once we start thinking of a REST API, we start thinking of these constraints. And the first one, of course, is RESTful APIs should have no state of any kind. And essentially what that means is everything that comes in a request to an API should have all the necessary data associated with it to let the server know what it needs to do. And this means that every single request should contain authentication. And this is different from a normal application whereby you have some sort of session that the server already knows about. And a RESTful API won't have this kind of session. So API keys would be submitted with a request to an API, and it will make the authentication at that time. And then the minute the API delivers the response back to the client, it simply washes its hands for it. It totally forgets that client ever exists. And even if that client were to make a second request directly back to the API again, it would re-go through the process of authenticating them because it has no state. And because it has no state, this makes a couple things really easy. Like for instance, scaling APIs become very simple when your application or your API is not stateful. You can just start cloning servers and clone 100 of them, no big deal, because every application is the exact same, it has no state, and it gets its authentication probably from a completely separate service, maybe a database server or a separate authentication API. So I just want to jump to a question here. Johnny Clue said, when will there be a REST standard? I think the closest thing to a REST standard that you're going to get is probably that doctoral dissertation and then all the stuff that kind of evolved around it. Will they ever formalize REST? I'm not sure. Maybe in like an RFC or something like that. But currently there is none. It seems to be working okay. And I think the reason they don't try to standardize it is because REST is kind of, it's sort of like agile development. Nobody's going to standardize agile development because that's just one group or one organization's way of saying, well, this is probably the best way to develop software. And the same is true for REST. People say, this is probably the best way to make APIs. And oftentimes people's good ideas often get used by others. And of course, here we are, with this thing we call REST APIs that end up being pretty close to the mark on how to make a perfect API. Threep said, I use Yi framework, or Yi, I'm not sure how to pronounce it, for making REST APIs. So once you start introducing frameworks into the mix for APIs, you start getting API features kind of out of the box. And oftentimes these frameworks will call it a term like blueprints or something like that. And essentially what they do is you define some database model, which would just be the table name and then all the fields and then the definition of what each field holds in terms of a data type. And then the framework just sort of wills this RESTful API into existence. And of course that's very easy, but in it being easy, you start lacking some of the configuration, around making the API what it should be. So I think I think frameworks play a role in enabling building APIs very easily, but I don't think that they should just be just just willed into existence, kind of out of nowhere. So, Tom asks, what's the best practice for writing a REST API? Should I design actions, methods, path, all up front? Yes, you should definitely do the designing of kind of sort of the first thing you do, and we're going to talk about this in a second, is you got to start thinking about like what resources you want your API to serve, and then from there it becomes clear kind of what URIs to make, to access those resources. What flavored popcorn do you like? I love buttered popcorn. I don't eat a whole lot of popcorn, but that's a good question. Okay, so moving on. So the second thing about restfulness is this thing we call separation of concerns. And this is where we start getting into, somebody, Leiden brought up microservices the other day. And separation of concerns is this idea that each thing can do something really well, each API. And so you have a server that does just server things, you have a client that just does client things, and then together they form this client-server relationship and the concerns are separated. Oftentimes people will create APIs and they think that they're true RESTful APIs, but what they really do is they return things like HTML fragments. And the problem with HTML fragments is it's not generic. HTML fragments are probably specific to an application, and right off the bat that just sort of kills it for being a REST API. That said, you can make APIs return a number of different encoding types. And this is where we get to this relevant header called accept. And we're going to look at this more later, but when you make a request to an API, you can specify a header value in the accept that is something like application JSON or application XML or text/HTML or plain/text. And not all APIs will support these additional types, but some of them will. So like if you want JSON, you simply say, my client accepts application JSON. And if you want XML, you say my client accepts application/XML. And then the API should return XML or JSON based on that request. However, APIs, they are allowed to say, hey look, I'm a JSON API only. You can't get anything else out of this API. So if you need XML, sorry, you're going to have to request the JSON and then convert it to XML. So, but just know that header does exist, and you should try it. Certain APIs will give you different data back based on what you put in that accept header. Yeah, Limitless says, would prefer JSON over XML. Absolutely. In 2019, you shouldn't be using XML unless you're working with legacy systems where they only support XML. In that case, it's probably fine to do it. So next is proper headers. So the headers in an HTML request, and let's actually look at one. So just for instance, we'll show what this does in a second. I'm sorry I couldn't make this bigger. I can't, it'll go smaller, but I can't make it any bigger. This is the biggest I can make it, so sorry about that. I hope everybody can read this fine. The headers for APIs, you have headers that you send to an API, and then you have headers that an API sends back to you. So I'm building this in a really, really, really lightweight framework that doesn't add any additional nonsense, but we have some headers here, some of which are important. We have the content type. It's saying that this is application JSON. We have the content length, lets you know how long the response is. We have an E tag, which is essentially a hash of the response. The URI response combo, you can actually store the E tag and you can know if something changed. So you can say like this URL or URI provided this payload that had this E tag, and then you can make another request and say, did the E tags match? If they do, then of course the response hasn't changed. But as soon as it does change, then the E tag changes. But another thing that comes into the headers is things like rate limits. If you're over the rate limit, then you'll start seeing rate limit headers. And of course, I haven't programmed that because this is a really basic API. But if you start working with APIs, you'll start seeing things like rate limits. In fact, we can make let's make a request to the GitHub API. Let's do GitHub. api.github.com. They'll likely have more headers. So you can see they have a ton of headers. They have, rate limit is 60. I have 59 remaining, and then it tells me when my rate limit gets reset. And I can simply calculate what the current Unix epoch of right now is, and I can just subtract that from it, and then I know how many seconds I gotta wait. Also, cache control, we're gonna talk about that in a second. In fact, let's just jump back to that. So the next thing in REST APIs is the ability to cache. And caching happens for a number of reasons, but primarily it happens to reduce the load on servers and reduce the load on clients making requests from servers, things like bandwidth. So it's important that a REST API be able to notify the client of how often things are cached. That way the browser can say, okay, well, I made this request and you're showing me that cache control here is max age is 60. So I know that I can treat this as accurate up to 60 seconds from now, and then I can, of course, request it. And clients can request new versions from an API whenever they want. This is just sort of a hint. It's saying that feel free to cache this request for 60 seconds, and then don't request it again if you don't want to. And this is all based on kind of the data that you're returning. There's going to be data that's going to be returned from an API that simply cannot be cached, things like real-time data. So you're likely going to see a cache control that's extremely low, or just, no cache, because that's one of the options. It can say no cache, meaning, don't cache this. So cacheability is important. And then the other thing is verbs. And some people are probably going to be surprised to learn this today, but there are more HTTP methods besides get and post. A lot of people think there's only get and post just because that's the only ones that are supported in the browser. When you make a form tag, yep, thanks for posting that in the chat. Insomnia.rest. It's free though. Great program. So yeah, the program I'm using is Insomnia REST client. You can feel free to download it. It's a very good program. It's free. And you can make HTTP calls with it and then analyze those calls. So, but back to what I was saying, there's additional HTTP methods beyond get and post. Things like put and patch and delete. And there's other ones like head, options, and trace. And those are kind of the ones that you might see. However, in an API, you're likely only to run across 5 when it comes to interacting with resources, and that's get, post, put, patch, and delete. And we're going to kind of use all those today. And these verbs, they relate to actions that you're going to take on a resource. So like post is what you would use when you want to create a resource, whereas get is what you would use when you want to read some resource. And the get verb has kind of a special property in that get requests should not modify any resources. And that's because get requests are, you can send a get request just by pasting a URL into the browser. When you do that, you're making a get request. Also, browsers can make get requests whether you want them or not, just to load content quicker. And then, of course, they stay in the browser history, and then they can get cached real easy. And because of that, you don't want all these endpoints out there modifying resources. So it's important to understand that get should be considered a safe action, which is to say that you can request a resource via the get method 1,000 times and nothing bad's going to happen. This is not true of post, put, and delete. Post, put, and delete are considered unsafe methods in that they take some action on a resource, whether that's creating or updating or deleting. So I guess TLDR, never delete a resource through a get method and you'll be okay. But that's what's meant by verbs. So it's important to use the proper verb on the proper endpoint for each resource. And you can see I've kind of done it here, and I know this is, you're probably not understanding what you're looking at here yet because I haven't written any code, but know that I've used get, post, put, and delete, across all these different endpoints to interact with certain resources. And we're going to look at the code. We're going to go over each of these. Every single one of these endpoints I have here are in my code, so I'll be able to show you all of those. And I think it'll be good. Make a request here. All right, great. So the next topic that comes up for APIs is authentication. And there's typically two ways this happens. One way is that you would generate an API key, which would just say, okay, well, with this key, you can supply it in the authorization header, another special header, and then you can say, this is my key that allows me to access this API. And then the application will actually look that up. And we can look at our code here. So one of our very first pieces of code we're going to look at is the authorization step, for the API. So what I'm doing here in code is I'm saying check the authorization header and see if it matches the string 123 ABC. And of course that would be a longer key, and of course it would be dynamic. People would, there'd be hundreds or thousands, tens of thousands or hundreds of thousands of API keys, and then it would look it up in a database and check it. But just for this example, I've just hard coded the key, and it's 123 ABC. And then if they are allowed, then great, send them through. They can continue making the request. If they are not allowed, then you hit them with a 401 status code. And this brings us into a whole separate topic of status codes. And again, some people may be surprised to learn that there are more status codes than just 200. Or you may not even be aware of a status code at all. Of course, everybody's heard of a 404 because the browser uses that status code. But there's a litany of other status codes that mean certain things and are heavily used in API design because you want to let the system know what the problem is, and you do that by way of these status codes. So one common status code that we just ran into is this 401 unauthorized. And this is considered a client problem, meaning that the server is functioning fine, the client just failed to send the right information. And in this case, they failed to send a proper API key, so we hit them with a 401. And then now they know. And we can replicate that here. If we go into our, if we go over here, and we just put the wrong header here, and you can see it says 401 unauthorized. Authorization is needed to get the requested response. And then that's all we get. We get a content length of 0. There's nothing here. Can't do anything with it. And then that's all you get. So that lets the client know that they are unauthorized and that they should try again. So API keys are simple, and that's the one we're using today. The other thing is OAuth 2. You often hear about OAuth 2, and OAuth 2 has kind of a separate use case. The reason OAuth 2 exists is to allow company A to access information about user A from company B. So one place that uses OAuth, if you've been on Engineer Man Knowledge Center, I use OAuth 2 to access Discord information via your session. And often the way OAuth 2 works is people start by redirecting their application to an application that user is signed into. So I redirect the user over to Discord. And then Discord says, hey, EMKC is trying to access data about you. Would you like to allow that? And then the user says yes. They say authorize. What it then does is it sends it back to EMKC with a code. Now what I can then use is I can then use the Discord API to exchange that code for an access token. Once I have an access token, which is generally limited in both time and scope, according to what the user allowed. So the user says, yes, they can have my name and my email. And then I get an access token that just allows me to access name and email. I can then use that access token, which is kind of like an API key, to then make a request to the Discord API to retrieve information about a user. And again, it's limited in time and scope. That token will probably expire in an hour, and it doesn't let me access any other data other than what the user allowed. So OAuth 2 is sort of like somebody vouching for another person to allow temporary access to an API about them. And that's why OAuth 2 exists. Like API keys couldn't work in that case, because API keys is just company A authorizes user A to access data. Simple. But this is different. This is company B asking user A to access data from company A about them. So the one we're using today is just straight API key, and it's probably the one that you're going to use the most of unless you're designing applications that people are going to integrate with, such as like Discord. Now, Discord expects that people will integrate with Discord, and that will require OAuth 2. And if you've ever made a bot, you notice that the bot doesn't use OAuth 2, and that's because you just take the API key, drop it in your bot, and you're done. And that's sort of that. There's no need to do OAuth 2. So next we're going to talk about, and this is the last thing we're going to talk about before we actually jump into the code, is we're going to talk about versioning. And if you look at my versions here, you'll notice I have /API/v1. And it's important to version APIs for a couple of reasons, but the most prominent reason is the fact that when you build an API and you release v1 of your API, people are going to begin using it. So if you have 100 or 200 or 1,000 or 2,000 people, 100,000 who are actually, integrating with your API, you cannot go and change that API later. You can't just say, oh well, I'm going to change the format of that endpoint. You just can't do it. The only thing you can do to an API is you can add to it. So if you have an endpoint that you want an additional property on, you can simply add that property. No problem. That's not going to hurt anybody. And then the same thing is true for if you want to add new endpoints. You could add a new endpoint under the same version just because that's not going to hurt any that's not going to hurt any current users of that API, but it's important to freeze the API at the time you versioned it to ensure you don't mess anybody up, because it's the worst thing you can do is start changing your endpoint signatures for people who are already out there. Like that's not, you as a developer, that's not a reasonable request to make to users. You can't say all 100,000 of you must rename this field in your application starting now, of course, because that breaks everything. So the way you combat this is at some point you say, all right, well, it's time to redo our API. We're going to make a ton of breaking changes. We don't really care, but excuse me, but we're going to call it a v2. Perfect. And then people are free to use v1 for as long as they feel like. And then you now work on v2 and you say all future integrations should be done against v2. And then at that point, you can say, hey, look, a couple of years from now, we're going to deprecate v1. We're going to stop supporting it. So you should consider upgrading to v2. But you can't do that suddenly. You got to give people options. And versioning is simple in APIs. You could just do v1, v2, v3, v4, 5, 6, 7, 8, 9, 10, 100, whatever you want. It doesn't make a difference. And that's probably the simplest way to do that. If you're working on an API where you require some specific versioning, then you can version it with v1.2.8 if you want. It's up to you. But, in the URL is a sensible way to do that. And then, so that's your version. And then everything after that, now we start talking about, okay, I don't know why I got this box here. Okay, everything after that, now we're referring to resources, and then now we're going to start getting into some code. Okay, I know that was a lot of info, but as we start building out the API, it'll start making more sense. So we have our authentication piece, and what we're basically building an API for today is we're building an API for authors, books, and then the relationship between books and authors. So, and I'm going to post all this code after the stream, and I put instructions at the very bottom of the notes section on how to get it working. That way you can make this exact thing work on your machine. So I have a file in here called schema.sql, and this has the definitions for a couple tables. The first table is the authors table, second table is the books table, and if you don't know MySQL, no big deal. Just know that the authors table has a ID, which will just be an auto increment ID. So it'll start at 1 and go up to, however many. And then it'll specify the name of the author and then when that author was created. And then the books is kind of the same thing. You got a unique ID for the book. You have a name for the book, when it was created. But of course, books are associated to authors. So we're inserting the author ID in the book. And then all I then did is I took 9 authors, and then for each author I inserted 3 books. So a total of 27 books. And then this is the data that we're going to use for this API. We'll be able to look up authors, look up books, look up authors which contain books, and then we'll be able to also, delete books, update books. Excuse me, lose my voice. I will be able to update authors and then delete authors, and then of course create new authors and create new books. And that's sort of going to be what we're going to want to do with our API. But know that this is the data that we're going to be working on. And I made it real simple. I didn't add a ton of properties, but feel free to experiment with this. Feel free to add a lot more properties, or change the name, or add additional tables. Feel free to experiment with this. So we won't need to look at this past this, but this is the data that we're kind of operating on. So the first endpoint we're going to make is one that we're going to call our authors resource. And keep in mind that resources, they don't necessarily have to map one-to-one to a table. Like, you don't have to expose the internal representation of your data to the API. They don't have to match. And we're going to see that later. We're going to have a resource for a table that doesn't exist. It's going to be one that we're going to kind of create from 2 tables to create one response. So the first one we're creating here is going to be the first endpoint of our authors. Okay, I did endpoints, but I meant resource. So the first one's simple, /API/v1/authors. Easy. And this is a GET request to authors, and it means we're just going to return all the authors. So I make my database call to find all the authors, and then I send it back. And I send a status code 200, because the 200 means that everything was okay. Now the reason I don't have other codes here is because this really can't fail. It's either going to find 0 or more authors, and in all cases it's going to be a 200. If the server encountered an error and it has a 500 code, it's probably not going to come from the application. It's probably going to come from the web server. So in this case, 200 is a sensible HTTP code, and this is a simple endpoint. And we can test this by going over here and doing read authors. It's a GET request, means it has no body, not sending anything to it. And then what we get over here is an array of objects in JSON containing the author ID, name, and created at. And that's it. Simple. So this gives us everything. If there's 100,000 in there, it returns 100,000. Is it compulsory to send status? So you have to send a status, but if you're using Express.js, 200 is the default. So you'll always send that, but you always do have to send a status, yes. It's absolutely required. I probably missed something, but how does the authentication part work? So the authentication part basically says, is the authorization header equal to this string? And if it is, then let them through. Otherwise, send them a 401, and that's it. But in practical matter, you would replace this with something a lot more complex. Is you would have this look up an API key in the database. You would then check if that record that the API key is associated with is authorized to, get a particular resource. You would check to see if it's active. You would check to see if they've paid their bills or whatever. So just know that you're going to replace this little piece of logic with something that's a lot more complex in the real world. But suffice to say, for this video, if the authorization header does not contain this string, which you can see over here in my header, I have authorization is 123 ABC, and that's good to go. So that's my authorization. If I take off the C, make a request, I get a 401 unauthorized. If I put the C back, then it goes through, no problem. And every single one of these endpoints that I've made for each of these resources has the same authorization header, every single one. You can see I click through all of them, and they all have that authorization header there. So that's how authorization works. I use Atomator. Yeah, so French Fruits, I'm guessing you're running API locally. Yeah, so I have a terminal. I have a terminal separately that I'm running API.js, calling just node API.js. And I've put that in the instructions here. If you want to get this working later, just npm install, load your data from schema.sql, update models.js, line 5 with your db config, and then you can run node API.js, and then this will run this exact application. But yeah, I do have a MySQL server running. I've already imported the data. I've already done npm install, and then I'm running API.js with Node. So I'm sort of just hiding that just because I'm trying not to make this about Node.js or anything. I'm trying to make this more about the API. So know that this makes a request to the database for all the records, and then this sends that data to the client with a status code 200. And hopefully that's easy to understand. So that was get all authors. The next endpoint would just be get one author. And the URL is pretty much the same, except we have this little placeholder here. So what we want people to send is /API/v1/authors/ and then ID. And then ID comes from the read authors endpoint. So like author ID 1, 2, 3, 4, 5, 6, 7, 8, 9, up to, of course I made some test ones, but up to 9. So to execute this one, you simply provide the number. So provide like a 1. And then the only difference here is when it makes a request to the database, it's getting just that author. But now, if no author is returned, you got to hit them with a 404. You got to let them know that that particular record is not found, and you let them know that by giving them a 404. If the record is found, you send them that author, and you give them a 200. Now we can try that out now. So we'll go to read author. Again, no body, but now I have this 1 here. And when I run this endpoint, I get just that author, number 1. If I change this to a 2, then I get the 2. If I change it to a 3, I get the third one, and so on and so forth. If I change it to a 300, I get hit with a 404. It says this is a resource that's simply not found. And this may be something new. Oftentimes when you go to a website, you get a 404, and often you think 404 means the URL doesn't exist, but what it really means is the resource that is pointed to by that URL doesn't exist. So in this case, this isn't saying that API v1 authors doesn't exist. It's saying that the ID 300 of API v1 authors doesn't exist. So you got to think of this more like an entity. This is one entity. ID 300 of the authors doesn't exist. So that's sort of that. And again, this is still simple code. We're just pulling one author out of the database. If the author doesn't exist, hit them with a 404. If it does exist, hit them with a 200. Send them the author. Sorry, simple. So that's kind of the two get all authors, get one author. Easy. The next one we're looking at is how to create an author. And this is also fairly simple. So you could see so far we're using the same base URL. It's always API v1 authors. It's just sometimes you provide the ID, sometimes you don't. But this is the same URL as getAllAuthors, except because you're using the post method, you are saying you should create a new entity. And this is kind of what we're doing here. So to create a new entity requires supplying the name of the author, and then it creates that entity. Now, I have two separate responses here, and you can choose whichever one you want, but you can either give them a 200 status code saying, yes, it succeeded, the entity was created, and then here is that entity, in this case an author. The other thing you could do is you could send them a 204 status code and send them nothing. So the 204 status code is no content. And then that means, oh, you know what? I made a mistake. I'm sorry. This was not supposed to be 200. This would be 201. So you can either hit them with a 201, which says the entity was created, and then the entity is also in the body of the response. The other thing you could do instead is hit them with no content. Say, I'm sending you a 204, which meant the entity was created, but I'm not sending you the entity back in the body. And we'll have a look at both of these. So with a 201, we can create an author, call it author name. So when I run this, you can see it says 201 created. It created a new resource, and it's also returned it in the body. It says author ID is 16, author name is, author name. So I can modify, I can comment this out, uncomment this, and then this will return them a 204 but no body. So in this case, when I run it, you can see I get 204 no content, but nothing's in the body. However, I am creating an author. Like if I put author name, Engineer Man, and I create it, if I go to now read authors, I scroll all the way to the bottom, you could see that Engineer Man is here, author ID 18. So it is in fact creating the resource. It's just returning you a 204 saying that there's just no content. But it was successful. Keep in mind, status codes that start with a 2 mean that it did work. It was successful. So you can pick one. It's up to you. It's up to you what you do. But they're both appropriate. So next thing we're getting into is the actual updating of an author. And this works a lot like the GET request for one author, except in this case it's a put. So the URL is the same as get one author, except because you're sending a put, you're saying update this author with the data that's in the body. And this is going to be the second one that we do, that we have to supply an actual body. So this code's a little bit longer because what it first has to do is it has to say, does this resource exist? So it has to look up the author by the author ID that's supplied. And if that author does not exist, you hit them with a 404. You let them know that this entity is not found. Can't do anything with it. But if it is found, you update the name, you save the author, and then again you can hit them either with a 200. A 200 is appropriate in this case because you're not creating anything. You're just saying that it's been updated. And then you can return the new updated author, or you can hit them with a 204, which is no content, and then return nothing. And again, that's totally up to you what you do. But we can check it out either way. So I'm going to update author 12. I'm going to supply the name in the body. I'm going to click go, and it says 404. It's not found because that author is not found. So we'll change it to an author that is found. Like, what was the Engineer Man one? 18. So I'll do 18, and that's it. It gives me a 200, and it returns me the updated entity of what that now looks like, which is now, author name. And then the last thing we're going to do is delete an author. So again, deleting is the exact same URL as getting and updating, except instead you're sending the delete HTTP method. And because of this, the same thing occurs. We look up an author, we check if that author exists. If it doesn't exist, hit them with a 404. Otherwise, say, author.destroy, and then hit them with a 204. And a 204 is probably the only appropriate one in this case because you don't want to send them an entity back that no longer exists. So it makes sense to say this was successful, but I'm sending you back no content. That's the most sensible HTTP code to send in this case. So that is our authors resource. With these 5 endpoints, we have the ability to read all authors, read one author, create an author, update an author, and delete an author. And if we move on to books, the same is true for books. Read all books, read book, update book, delete book. However, we do have 2 special endpoints called read author books and create author book. And these have URLs that are kind of non-standard. So if we look at read author books, we can see that our endpoint is API v1 authors/1, which is going to be the ID for the author, but then you're doing /books. So this is kind of a sub-resource where you get the books for an author. So if I run this, what I get is I get all the books for one author. And the reason you want to do it like this is because these books are a sub-resource of the authors, and you should provide that in the URL. However, if you just want to read all books, it's just /books. And if you want to read one book, it's /book/ and then the ID of the book. And then the same with updating and deleting, because if you already know the unique ID of the book, you can just use generic update and delete book endpoints. But when we're talking about creating author books and reading author books, you have to supply the author in the URL. So in this case, you do, to read author books, we have that. To create an author book, it's the exact same URL, except it's the post method. So I'm supplying here the book name. So what I'm doing right now is I'm creating a new book for author ID number 1. So when I click go, and it returns me that entity. It says, I'm giving you a new book ID 30. It's attached to author ID 1. I'm getting a 200, although that should have been a 201. And then name is book name. So, and that's sort of the rest of these endpoints. I don't necessarily need to re-go over the book ones. We're sort of running low on time, so I got to speed up here. But just know that if you are working with a resource that is sub to another resource and it depends on that parent resource being available, then you should do it this way by putting both resources in the URL. So the final thing we're going to look at is what happens when you want to create a new resource that is kind of 2 resources together. So I've created, and I'm just going to scroll down a lot here. Scroll to the very end here. So I've created this new resource that I'm calling author books. And what author books are, not necessarily the books that belong to an author, but an author and their books in one resource. So I've created this here where I'm basically just getting all authors, but I'm also including their books. And then I'm sending that to the user. So I'm going to execute this now. And you can see in the response, it's a little bit different. I now have an array of objects representing each author, but then in that same object, I also have an array of books, which are represented by an object. So, and the reason you would want something like this is you got to kind of look at how people are going to use your API. If it's common to get an author and their books in the same response, then it makes sense to offer up this sort of resource. Because if, like, imagine you didn't provide this. If you didn't provide this and somebody was querying 100 authors, the only way for them to get all the books for every author would be either to query all the authors and all the books and sort of like merge them together, or make an API call to get all the authors and then make one API call to the books per author. The problem with that is if you query for 100 authors, you make 101 API calls, and that's not acceptable because that's extremely non-performant. So this is a way of offering a resource that kind of contains both at the same time. And I've only included two here because author books, you don't have the ability to. This is sort of like a read-only kind of thing. You wouldn't delete collections like this. You would just read them, and that's that resource. So, and then the same thing works with just a single one. If you just want author ID 1 or 2, you can just put that at the end here. So this gives me one author, which also contains all their books in that same response, and this makes it easy to work with. But keep in mind, the same can be achieved by, reading author number 2, and then proceeding to read author books for number 2. Between those two things I just did, read author and read author books, I got the same data as I got with this particular one. It's just I had to make 2 API calls versus 1. And again, whether you design these sorts of resources into your API is all based on what you perceive the use case to be, or the use cases to be by the people that will use your APIs. And that's sort of it for the code. The rest is, like, a lot of this code is just, a duplication of the author's endpoints that function on books. So it's a lot of it's the same. But I will, as I said, I'll definitely post this on GitHub, and you'll be able to interact with this just as I'm doing. So no problem. I might even post a Docker container just so you can just start it without any effort at all, and then make it easier on people. Okay, so let's jump into some questions, and we only have like 4 minutes left, so let me try to get through some of these. Hopefully all that was very easy to understand. I know I went through some of it kind of quick, but I think if you look at the code and then you look at the other thing I'm going to do is I'm going to post the Insomnia HTTP collection. I'm going to post it also in GitHub. That way you could just import all of these endpoints right into your Insomnia. And if you use Postman, this is just in my opinion, again, this is preference. I think it's a better Postman. But I'm not sure if you can take Insomnia collections and import them into Postman, but certainly try that. Maybe it'll work. Otherwise, just download this program and then use it this way. So let's get into some questions here. Hopefully I answered a lot of people's questions that I said I would answer in the course of this. If not, certainly let me know. Okay. Is there best practices I should follow when prefetching data so the UI doesn't get so bogged down while reducing API callouts? So one common thing to do with a RESTful API as it relates to UIs is to just render the shell of a UI and then start requesting data from an API to start filling out that UI. That's a pretty common thing. That's the like Angular 1 to 4 and 5 model, as well as the Vue.js model, and to a lesser degree React, because React can take data from either data that comes from an API or data that's just a response that's just in the same response that renders the UI. So the best practice is, if you want a really performant UI, the best way to do it is just render the shell and then start rendering all the data in that shell via API calls. How to update APIs in production without taking the server down. So the best way to do that, we talked about this on a previous stream on how to do like 0 or no downtime deployments. The only way to do a 0 downtime deployment is to have a set of servers running one version over here, and then a set of servers running another version over here, and then you're basically just throwing a switch that just cuts all the traffic over to the other bank of servers. And that's kind of the only way to accomplish, like a true 0 time. To minimize downtime, you can a lot of the stuff you could probably upgrade in place, because if your API, again, you don't want to break your API anyways. So if you're just adding new things to the API, it's not that big a deal if only half the servers have half the code, because your change shouldn't break anything anyways. So if half the servers have one property but half the servers don't, it's not that big a deal if there's like, it's not really downtime, but it's okay if there's a period of time where the APIs are inconsistent, because you can communicate that ahead of time and say we're rolling out new code, between this times, the API will continue to operate normally. However, some responses might have additional properties, but as of this date and time, it'll be fully rolled out. So, yeah, no big deal. Using async in the rec res, anonymous callback, and express wraps on a promise. Doesn't express do that automatically? So the reason I'm using async is because if, this is JavaScript specific, to use this await keyword requires that it be in an async function. So that's the only reason that's there. If I were to take this out, then it becomes a syntax error. See, when dealing with something like registered users, is it okay to return their ID in the database, or should you abstract it away somehow and use something like UUID? So that's all based on your application. In most cases, a user's unique ID is not a security risk, but that's entirely based on your application. Of course, if it was like a social security number, you wouldn't want to give that out. But I mean, if it's just the user's unique ID in your application and it has no other reference outside of your application, and it can't be used to steal their data or do anything nefarious, then I think it's fine to show it. If you want to use a UUID, the thing about using a UUID in place of an ID is essentially a UUID is now the new ID, and if the ID had a risk, then the UUID probably has a risk as well. So I think, in short, I think ID is fine. Chris John, this is a great question. Thank you for this. Is there any general best practice for when to delete a record versus when to flag a record as inactive? So, in software engineering, we often call this a soft delete, whereby it's the application, rather than actually deleting the record, simply marks it, as you said, as inactive, or like is deleted equals 1 or something like that. And the best practice in my mind is if you might need to restore that data at a later point, then it makes sense to soft delete it. And then also if you work in an industry, like I worked in an industry that had like a huge compliance regulation structure, and it required keeping data ready and available for up to, I think, like 6 months. So we could never really delete anything that wasn't older than 6 months. And because of that, we had to soft delete everything. And so that would be one of those times where you would just soft delete. The problem with soft delete is it adds a lot of application complexity, because every one of your queries has to look at, is this record active? And then you got to make sure that not everything is soft deleted, so the queries just become more complex. But that wasn't your question. Your question isn't is it more complex to write soft deletes? Is it it's when's the best practice to do so? And to reiterate, I think it's if you ever have to undo something quickly, or you have to comply with some regulatory structure. Do you use environment variables to hide secrets and keys? How would one hide sensitive info before checking into version control? Yes, so generally what I do is I use an environment file. Often I use like .env. So every one of my projects has a .env and a .env.sample. And then the .sample gets checked in to the code, the code repository, and what the .sample has in it is all the keys without the values. And then when I get it into production or whatever, I do a CP on the env sample into the env. And then I modify the env to actually contain all the secrets and all the configuration. And this doesn't just have to be done with secrets. It can also be done with things like environment equals production or environment equals development. So even things that aren't sensitive, you would still put in there because the things you're putting in there are things that are specific to the machine that it's currently on. And that's a good way to do that. I found that that's a sensible way of handling it. And for the .env, you can either just reference the .env directly, or you could just push all the values of the .env file into the actual system environment. And whether or not you would do that is just based on, again, your use case. I think I hit all the questions. We're about 5 minutes over. I apologize for that. Hopefully, I think I got everything. I'm not seeing anything I missed. So, okay, so let's wrap up. So that's APIs. You know, we talked about a lot of things in this video, and that's why I didn't want to linger on some stuff in the beginning. I knew we had a lot to go over. This is also why I didn't try to write all this code, as we were going. And so, yeah, APIs are very complex, but they don't have to be. They can be split out into smaller pieces to make them a little more manageable. But there's still a lot of pieces that go into it, and it's one of the most popular things that are kind of out there right now. There's APIs everywhere because interconnection between components is just a lot more, prevalent today in 2019 than it was kind of in the past. So if you want to continue this discussion about APIs and things like that, you should definitely come over and check out the Engineer Man Discord server. And somebody will post a link in the comments here in a second. We got about 5,000 people over there. I'm present there quite a bit. So if you want to say hi to me, I'll always be there. And I'm always up for a good conversation on past videos or streams or things that people just don't understand. Sometimes I get Discord voice chats going, and we can chat about it more there. And yeah, so it's a good place to be. It is very helpful. There's a lot of active people, a lot of smart people there, and you should come check it out if you haven't already. Also, I think we're at like 4,993, so you might actually be the 5,000th person if you go there right now. So it'd be kind of cool. And yeah, so simply you can drop me a line there. I don't block people's messages. All I ask is that you be respectful of my time and other people's time. So if you're able to get help in one of the channels, certainly ask there. But if you want to say hi to me, feel free to send me a message. No problem. Other than that, again, thanks to all my staff for helping make this happen. Thanks to all the regulars who come into the streams all the time. I see the same names a lot, and it's the same people coming every Tuesday. There'll be another stream, as usual, 2 weeks from now at the exact same time, which will be noon Central Time. I don't know if it's Standard or Daylight. And that'll be 2 weeks from now. I might do a video tomorrow. I know I have some personal obligations I have to handle that I might not get it out, but I may. And as far as this code, be looking for this full code in the next probably hour or two. I got a couple cleanup things I want to do, and then I'll make sure I post that. And then just make sure you check out the stuff at the bottom of the notes.yaml file, and it'll tell you how to get this running. All that's really required is that you have a database and Node.js installed, and then you can get it working. And it'll be cool. Other than that, if there's any questions I missed, throw them in Discord. Otherwise, I hope everybody has a fantastic rest of your weekend, and I hope to see you on the server or on the next video or on the next stream or perhaps all three. So have a good weekend, and I'll catch you later.